This is question 2A3 from March 19, paper 4. So this question is asking us to refer to this table to use for each of magnesium, strontium, and barium, whether or not a saturated solution of its hydroxide could be used for the test of carbon dioxide. Now, before the question, they gave us an example by using calcium hydroxide. Calcium hydroxide is the salt used in lime water. We often use lime water to test the presence of carbon dioxide. So when carbon dioxide is passed through a saturated solution of calcium hydroxide, then a white precipitate of calcium carbonate is formed. Now let's look at the table. We are given solubilities of group 2 hydroxides and also group 2 carbonates. So let's use calcium hydroxide to explain solubility. 1.5 times 10 to the power of negative 2 is the solubility of calcium hydroxide, meaning this is the maximum number of mole of calcium hydroxide that is soluble in 1 decimeter cube of water. If the concentration of calcium hydroxide exceeded this number in the solution, a precipitate of calcium hydroxide will form. Same goes to the carbonate of calcium here. So this will be the maximum concentration of calcium carbonate that is still soluble in water. Once concentration exceeded this number, the carbonate of calcium will form, which is a precipitate. So now why, when carbon dioxide is passed through a saturated solution of calcium hydroxide, a white precipitate of calcium carbonate is formed? Right, the reason is because calcium carbonate has lower solubility of calcium hydroxide. In a saturated solution of calcium hydroxide, the concentration of calcium 2 ions will be 1.5 times 10 to the power of negative 2 mole per decimeter cube. How do I know this number? Okay, it is from the solubility of calcium hydroxide. So saturated solution means we now have the maximum number of mole of calcium hydroxide in the 1 decimeter cube of the solution. So 1 mole of calcium hydroxide dissolved in water will give us 1 mole of calcium 2 ions and 2 moles of hydroxide ions. That's how I know the concentration of calcium 2 ion is the same as the solubility. When carbon dioxide is passed through this saturated solution, calcium carbonate will form. So calcium 2 ion will react with carbonate ions to form calcium carbonate. Now, if this is the concentration of calcium 2 ion, when we pass through carbon dioxide, the highest concentration of calcium carbonate that will form is 1.5 times 10 to the power of negative 2. The maximum concentration will not be higher than this 1.5 times 10 to the power of negative 2 because that will be the maximum amount of calcium 2 ions in the solution. So now let's check if this concentration has exceeded the solubility of calcium carbonate. Yes, 1.5 times 10 to the power of negative 2 is higher than 1.3 times 10 to the power of negative 4. So what did I say just now? When the concentration of the salt is higher than its solubility, a precipitate will form. So that's the reason why when CO2 is passed through a saturated solution of calcium hydroxide, a precipitate of calcium carbonate will form. So for strontium and barium, the solubilities of their carbonates are also lower than the solubilities of their hydroxide. When CO2 is passed through the saturated solution of strontium hydroxide and barium hydroxide, the concentration of the carbonate will exceed the solubility of these two carbonates. Therefore, both strontium hydroxide and also barium hydroxide can be used to test the presence of CO2. Now let's look at magnesium. Magnesium is different. The solubility of its carbonate is higher than solubility of its hydroxide. So let's use this same working saturated solution of magnesium hydroxide. I get magnesium ion and also hydroxide ions in the solution. Now saturated solution. The concentration of magnesium ion, highest concentration of magnesium ion in this saturated solution will be the same as its solubility. So when CO2 is passed through this magnesium hydroxide solution, the highest concentration of magnesium carbonate formed from this reaction will be 2 times 0 times 10 to the power of negative 4 mole per decimeter cube. Let's compare this with the solubility of magnesium carbonate, which is 1.5 times 10 to the power of negative 3. 2.0 times 10 to the power of negative 4, the maximum concentration that will form is lower than its solubility. So all this magnesium carbonate is soluble in water. Therefore, no precipitate of magnesium carbonate will form. So if CO2 is passed through a saturated magnesium hydroxide solution, no precipitate will ever form. So we cannot test the presence of CO2 by using saturated magnesium hydroxide solution. So the only hydroxide that is not suitable to be used for the testing of carbon dioxide is magnesium hydroxide. So the rest are suitable. Therefore, the answer, strontium and barium could be used and magnesium could not be used. And the reason is because solubility of magnesium carbonate is more than magnesium hydroxide. Or you can say solubility of strontium carbonate and barium carbonate are less than the solubilities of the hydroxides.